Hello everyone, in this video we will be solving problem 35, search insert position. The problem statement is, given a sorted array of distinct integers and a target value, return the index if the target is found and return the index where it can be inserted in the order. We need to write the algorithm using O of log n runtime complexity. In example number 1, we have 1, 3, 5, 6 and the target is 5. As the 5 already exists in the array, we are returning its index, which is 2. In example number 2, the target is 2 but it doesn't exist in the nums, so we'll place it right between 1 and 3, so the output is 1. Similarly, in example number 3, we have 7 which does not exist in the array. Based on the numbers that we have, 7 should be placed at the very last after 6. Its index will be 4. Solving this problem using the naive approach, where we'll iterate through all of the numbers once and figure out where it should be placed, will solve the problem, but its time complexity will be O of m, where m is the number of characters in the nums array. Although it will solve the problem, it will not solve the problem with the time complexity that the problem statement is asking for. So now let's talk about how we can improve the solution to match the time complexity requirement. A couple of very important statements that are given to us in our input problem is, array is sorted in an ascending order and all of the values in the array are distinct. So we can be sure that there won't be any duplicates and everything is ordered correctly. We can use the divide and conquer approach, where we'll take the array and start breaking it down into half and only focus on one side of the array to see if the target that is given to us can fit in over there. Let me show you with a couple of examples. So with nums 1, 3, 5 and 6 and target as 2, instead of iterating through the entire array from start to the end or end to the start, we'll start by identifying the element that is at the very center and then compare it against the target value. So my first index would be 0 and the last index would be the last character in the array, which is 6. The index would be 3. What is the middle? So 0 plus 3 divided by 2. If it is an odd number, we'll take the higher one. So 0 plus 3 is 4. 0 plus 3 is half is 1.5. So we'll take the math dot ceiling, which will be 2. So what is the corresponding value at nums of 2? It is 5. Is 5 greater than 2? Yes, it is greater. So certainly 2 cannot be placed in the second half of the array. It can only be in the first half of the array. So with this information, we'll update our boundaries. So my new boundary will be 0 and 2. We'll do the check again. Its corresponding value, the value at index 1 is 3. Is it greater than 2? Yes, it is greater. So again, I'll update my boundary and change the last index to 1. And now because the first and last are next to each other, we can safely put the number 2 at index 1. If you think about the iterations that we did right now to solve this problem, the first was to figure out the middle, which gave us 5, that's 1. The second iteration was between 1 and 5, and then 1 and 3. So in 3 iterations, we figured out where 2 can be placed in the nums array. Because we are using the divide and conquer approach, our time complexity is O of log n, where m is the number of characters in the input array and the space complexity is O of 1. Let me show you how we can implement this using C#. In this solution, I start by initializing 2 pointers, the first and the last, and setting the default values as 0 and the nums.length minus 1 respectively. I then start the while loop, where first is less than or equal to the last one. We'll run this iteration, or we'll run this divide and conquer approach until this condition is met. I then calculate the middle, which is first plus last divided by 2. If the target is equal to nums.mid, then we simply return the mid. This is to cover the case where the number already exists in the array. If not, then we check if target is less than nums of mid, which means the target is in the first half of the array. If that is the case, we update the last index with mid minus 1. Else, we focus on the second half, for which we need to update the first pointer. After the iterations are complete, we'll have the index in the first variable. This approach beats 100% of the summations made on LeetCode so far, and almost 39% of the summations in terms of memory consumption. I hope you were able to understand this solution. This link to the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.